Hello and welcome back. So in the last chapter, thermochemistry, we talked about why some reactions happen, right? We talked about entropy and enthalpy. Entropy being a measure of chaos and enthalpy being a measure of heat that is either released, exothermic, or absorbed, endothermic, in a reaction. So we saw that Gibbs free energy will tell us if Gibbs free energy is negative, the reaction should happen spontaneously, and if Gibbs free energy is positive, the reaction will not happen spontaneously. And do you remember what is the equation for Gibbs free energy change? It's change of G equals change of H minus T times change of S, right? So Gibbs free energy tells us whether a reaction will happen or not. Well, consider this case. We have carbon in a tetrahedral arrangement bonded to another carbon at every single bond. This is a diamond, okay? So it looks literally like this. We have carbon, and then a tetrahedral arrangement is when there's four things bonded to it, and one is coming out at us, that's why we have that, and one is going back into the board, and we have that, okay? So this is the structure of a diamond. Doesn't it look beautiful? Yes, so that is it. So, and then we also have graphite, okay, which makes up the this part of the pencil. And graphite, is a much more chaotic composition of carbon, but it also only contains carbon. So here we have two different connectivities for carbon. The diamond, the very ordered and very complex, okay, system. And then we have graphite, much more kind of loose system. And remember how we talked about that reactions happen because the atoms want to get to the lowest energy state possible. Well, what if I told you that actually graphite is at a much lower energy than diamond? Okay, the atoms in there. So which one would they prefer to be in? The carbons, they want to be in the graphite form, not the stressed out tetrahedral diamond form. Okay, so if I told you that this is an exothermic reaction to go from a diamond to a graphite, because graphite is at a lower energy level than a diamond, so energy is released, it's exothermic. And if I told you that entropy, which is S, remember, that change of entropy is also positive because graphite is not as ordered as the diamond is. Okay, so here we have both factors pointing us in the direction that this is a spontaneous reaction. We have a negative change of H because this is at a lower energy, and we have a